What happens if someone gets lost in the space? When someone gets lost in space, their fate is governed by the physical laws of motion and the environment of space itself, which is vastly different from Earth. Let's explore more about where they might end up, what influences their trajectory, and what conditions they would face. Orbiting a celestial body. If the person is near a planet like Earth, the Moon, or even a large asteroid, they could enter into or continue an orbit around that body. This means they would be caught in the gravitational pull of the object and circle around it. Depending on their altitude and speed, they might stay in orbit for a long time or eventually spiral down toward the surface. If they were orbiting Earth, they might gradually lose altitude and re-enter the atmosphere, where the intense heat from friction could cause them to burn up. If the body lacks an atmosphere, they could crash directly onto its surface. Drifting in space. If they are in deep space, far from any significant gravitational influence, they would drift endlessly in the direction they were last moving. Space is so vast and empty that the likelihood of encountering another object or even another spacecraft is incredibly low. This drifting could continue for millions or even billions of years, theoretically until they reach the end of the universe or are captured by a distant star's gravity. Captured by gravity. Over time, the person might be slowly drawn toward a nearby gravitational source, such as a planet, star, or black hole. The strength of this pull would depend on their proximity and the mass of the object. If they were drawn into a star's gravity, they could eventually spiral inward and be incinerated by the intense heat and radiation. If they were pulled toward a black hole, they would face a different fate, being stretched and compressed in a process known as spaghettification before being absorbed by the black hole. Interstellar travel. In the unlikely event that they drift far from any solar system, they could enter interstellar space, the vast regions between stars. In interstellar space, the distances are so immense that even traveling at the speed of light, it would take years to reach the nearest star. Since humans cannot travel at such speeds, the person would continue drifting indefinitely, possibly until the end of their oxygen supply or their life support systems fail. Vacuum of space. Space is a near-perfect vacuum, meaning there is no air and therefore no oxygen. If a person's spacesuit were to fail, they would quickly lose consciousness due to the lack of oxygen. Additionally, the lack of pressure would cause the gases in their body to expand, leading to a painful and fatal condition known as embolism. Blood and other fluids could start to boil at body temperature, leading to rapid death. Temperature extremes. The temperatures in space can vary drastically depending on whether an object is in direct sunlight or in the shadow of a celestial body. In direct sunlight, temperatures can reach up to 250 degrees Fahrenheit, while in the shadow they can plummet to minus 250 degrees Fahrenheit. A spacesuit provides insulation, but if it fails or the life support system runs out, the person would be exposed to these extreme temperatures, leading to heat stroke, hypothermia, or frostbite. Cosmic radiation. Space is filled with cosmic rays and high-energy particles emitted by stars, including our Sun. Earth's atmosphere protects us from much of this radiation, but in space, astronauts are exposed to much higher levels. Over time, exposure to cosmic radiation can lead to radiation sickness, increased cancer risk, and other serious health effects. In the short term, high doses could be lethal. Isolation and psychological effects. Being lost in space would be an incredibly isolating experience. The person would be completely alone with no hope of rescue. The psychological effects of such extreme isolation and the knowledge of their impending death could lead to severe anxiety, depression, and other mental health issues. Even highly trained astronauts might struggle with the extreme loneliness and fear associated with being lost in the infinite expanse of space. Potential for rescue. If a person lost in space, rescuing them would be an extraordinary challenge. Space agencies like NASA or ESA would need to track their location accurately, which could be difficult if they drift far from the spacecraft or station. Even if their location were known, sending a rescue mission would be highly complex, requiring precise calculations and timing. The rescue craft would need to match the lost astronaut's velocity and trajectory, which might take days, weeks, or longer depending on the distance. The most pressing issue in a rescue operation would be time. The astronaut's life support system, particularly oxygen, would only last a limited amount of time, usually hours or days. A rescue mission would need to be launched quickly and travel at high speeds to reach them before their oxygen runs out. The vast distances in space make this an extremely difficult task. Speculative and long-term possibilities. While highly unlikely, the person could, in theory, encounter other objects in space, such as asteroids, comets, or even alien technology, though this remains purely speculative. If they were to drift into a debris field or encounter a micrometeoroid, they could be struck, potentially causing their spacesuit to be punctured and leading to a rapid death due to exposure to the vacuum of space. If no other object or gravitational force affects them, the person could drift eternally through the cosmos. They would become a tiny, frozen, lifeless object traveling through the universe indefinitely. In billions of years, they might be absorbed by a star, black hole, or planet, or continue drifting until the end of the universe itself. In summary, getting lost in space leads to extremely serious and dangerous outcome, all of which end in death unless a highly improbable rescue occurs. The person would drift according to their last direction of motion, possibly entering orbit around a nearby celestial body, being drawn into a gravitational pull, or drifting endlessly through interstellar space. The harsh environment, including the vacuum of space, extreme temperatures, radiation, and isolation, would contribute to a rapid and inevitable demise. While the vastness of space provides a certain degree of awe and wonder, it also underscores the stark reality that space is an unforgiving and lethal environment for humans without the protection of a spacecraft.